Alright, so this question is January 2014, question 6b, and it says the diagram below shows triangle JKL and its image J prime, K prime, L prime after a transformation. We're asked to state the coordinates of the vertex J of triangle JKL. Alright, so we're asked to state the coordinates of the vertex J. So this is J here, where the x coordinate is 4, the horizontal coordinate is 4 minus 4, and the y coordinate is 1. So J, the coordinate of J is minus 4, 1. The vertical coordinate is minus 4, and the horizontal coordinate is 1. So J is the point minus 4, 1. Next, we're asked to state the length of KL. We're asked to state the length of KL of triangle, sorry, of K prime L prime of triangle J prime K prime L prime. So we're asked to state the length of K prime L prime, which is the length here, and we can see that this is 2 units. All right. So I can say that K prime L prime is 2 units long. K prime L prime is 2 units long. Alright, next, the third thing we are asked to do is to describe the single transformation that maps triangle JKL onto triangle J prime K prime L prime. Alright, so looking at it, looking at this, in order to answer the third part of the question, we'll at least have to examine the diagram, and from looking at the diagram I can see clearly that it's not a translation, because some amount of turning occur with this diagram, and translation is moving in a straight line without turning. It doesn't look like a rotation, because if it was a rotation it would be a 180-degree rotation. And in a 180-degree rotation, 180 because it actually went through what through two quadrants. It skipped a quadrant and moved from let's say one quadrant to the third quadrant. It skipped a quadrant, so I know that it is not a. So in looking at it, I know it's not a 180-degree rotation. It's definitely not 90, because with 90 you move from one quadrant to the next quadrant. And it's not a 180-degree rotation, because in a 180-degree rotation, horizontal lines would remain horizontal and vertical lines would remain vertical. So it is not a rotation. The third thing is this. It's not an enlargement. It doesn't look like an enlargement. And so the only other transformation that remains is what? Reflection. It's not a reflection in the y-axis. It's not a reflection in the x-axis. All right, so I'll tell you what it is, and then I'll come and show you. So to answer the third question, I would say that, so to describe fully a single transformation that maps triangle JKL onto triangle J prime K prime L prime. I would say that triangle JKL is mapped onto, the arrow here means is mapped onto triangle J prime K prime L prime by a reflection in the line y is equal to x. It's a reflection in the line y is equal to x. Alright, let's draw the line y is equal to x. The line y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. The line is y is equal to x, so whatever the x coordinate is, the y coordinate is also the same thing. So this is the line y is equal to x. It is a straight line that passes through all points on the graph where x and y have the same value. Now, whenever you reflect in the line y is equal to x, you can evaluate, one way you can do it is you must evaluate the distance diagonally. So diagonally, this is L is one diagonal, L is one diagonal, two diagonal, L is two diagonal from the mirror lines, and the image L prime has to be the same distance on the other side. So it's one diagonal, two diagonal, but on the other side. So in a reflection, both the object and image are the same perpendicular distance from the mirror line on either sides of the mirror line. If you look carefully, you'll see the same thing with K, one diagonal, and with J, you have what? One, two and a half diagonal, the image, sorry, the object, one, two and a half diagonal. So I can clearly see that this is a reflection, and it's a reflection in the line y is equal to x. So in a reflection, both the object and the image are the same perpendicular distance from the mirror line on either sides of the mirror line. And the mirror line is the line y is equal to x. The mirror line is the line y is equal to x. All right, the last part of the question. All right, so we can erase some of this. If we want, we could erase the mirror line as well. I guess it doesn't necessarily need to be there. All right, the last part of the question says, state the coordinates of triangle J double prime, K double prime, L double prime, the image of triangle JKL under the translation by the vector 5 minus 3. All right, so we're asked to state the coordinates of J double prime, K double prime, L double prime, the image of triangle JKL under the translation by the vector 5 minus 3. So we're going to move JKL by the vector, this is JKL by the vector t, which is 5 minus 3. For translation, the top value describes your horizontal movement, and the bottom value describes your vertical movement. So a translation of 5 minus 3 means that I must move JKL 5 units to the right and 3 units down. If I did that, I could do this for L. 5 units to the right, 1, 2, 3, 4, 5, and 3 units down, 1, 2, 3. So the new position of L is going to be 4, 0. The new position of L is going to be 4, 0. So the new position of L is going to be here. All right, so let's just say that would be my L double prime. My K double prime is going to come here. All right, K double prime, and 1, 2, 3. My J double prime is going to come here. So this is J double prime. If I wanted to, I could test all of them and show you that it is true. I'm asked to move what JKL 5 units to the right and 3 units down. So for J, 1, 2, 3, 4, 5 units to the right, 1, 2, 3 units down. That would be the new position of J. All right. For K, 5 units to the right, 1, 2, 3, 4, 5, and 3 units down, 1, 2, 3. That would be the new point of K, which would be K double prime. So I move all three vertices, J, K, and L, 5 units to the right and 3 units down, effectively moving JKL in a straight line without turning. All right, so from that now I could say that IV, that J um, J double prime would be the point 1 minus 3, that K double prime would be the point 4 minus 3, and that L double prime would be the point 4, 0. Alright, I completely messed up here. Alright, so let's just correct it. This is actually it's actually 1 minus 2 and 4 minus 2. Alright, so it's minus 2 and not minus 3. Alright, another way we could probably approach this is that we could probably use the matrix equation of transformation. Sorry, the matrix equation of transformation, which technically would be that J double prime, K double prime, L double prime would be J, K, L plus T. Alright? Or you could say J is equal to J double prime is what? J plus T. Alright, that's the matrix equation of transformation. Alright, so let's put in the coordinates of J. Alright, the coordinates of J is minus 4, 1. The coordinates of K is minus 1, 1, minus 1, 1. And the coordinates of L is minus 1, 3. So this is minus 1, 3 plus T, and T is 5. T is 5 minus 3. Alright, so if we finish this, we would have what? Minus 4 plus 5 and 1 minus 3. We would have minus 1 plus 5 and 1 minus 3. And we would have minus 1 plus 5 and 3 minus 3. And so we would end up with 1 minus 2. We would end up with 4 minus 2. And we would end up with 4, 0. So again, J would be 1 minus 2. That's J double prime. K double prime would be 4 minus 2, and L double prime would be 4, 0. Alright, so that is an alternative approach to the question.